Is anyone there? It's gone silent.
We're
Okay.
here.
All
Can you
right.
hear us?
It's just so unusual for that lot to be quiet.
Yeah, we just mute ourselves until we start the session in 3
Okay,
minutes.
that's fine. Yep.
Thank you.
Okay, team, do we want to get started?
Yes, Leslie, we absolutely do want to get started. Hey, everybody, welcome to the room. Feel free, don't worry, there's not going to be like assignments, so it's okay to sit in the front. It's safe. And Leslie, please go ahead and kick us off.
Okay, well, welcome everyone to this session from the Earth, Space and Environmental Sciences Intergroup. The title of this session is Continuing the Circle of Life of Earth and Environmental Science Data Infrastructures Projects. And we're going to hear about a few that are maturing. Next slide, please. The it's the ESIP. Back one, please. It's the ESIP RDA group. And we work towards coordinating and harmonizing multiple international efforts, both in interdisciplinary and domain-specific FAIR data infrastructure development, vocabularies, and common digital data services. Through open communication, we're doing our darndest to avoid duplication, increase efficiency, and share use cases. And so we're really about sharing information at a high level on projects and finding out who is doing what where. Next, please. So the objectives of this one is to continue our mapping, raise awareness in some lightning talks of new projects, and review a couple of major projects. We've been going 5 years, so it's only natural in the circle of life that some of our projects would end. And hopefully they can tell us what worked well and what we can learn from them. Next. So the current status, as I said, is we've been running since 2017. And our two major outputs are a data infrastructure catalog and a semantic resources catalog. So we have the data infrastructures in the first one. The second one stores list of vocabulary services, ontology resources, etc., etc. And they're actually becoming fairly widely used. But we really want new additions, and we'd love more from the Global South in red here. We're particularly trying to reach out and see if we can get more participation. We know there are great projects going on there. Please let us know about them. Above all, we are bottom up. We just work as a local community sharing knowledge, and we want to leverage from each other and stop reinventing the wheel. Okay, so our agenda is absolutely jam-packed because we weren't able to organize the sessions the way we thought we were. We had hoped we could have 2 breakouts, but we've had to run it all into one. And so please yell out if you want to participate and have a comment. Or better still, we've got the session notes that are in the chat. Can you please put your name and affiliation in those? And any notes or comments you want, just feed it back to us through that. So we're just going to have a quick review of our catalogs, what's new in them. We're then going to go into new lightning presentations on some new ones. And then we're going to do some deep dives on PARSEC, ENVRI-FAIR, and then do a wrap up. Next slide, please. Sorry, someone's asked for the notes. I'm just giving them to them. So I've put them there. Please put your name in it. Okay, so I just want to give you some updates. We've added some quite new major projects that are kicking off in Europe and one in the US. But please note, we haven't got any new ones from the Global South since our last plenary. So please help us out. And I've only just added the names to them. So if there's anyone in the room who has something to do with those projects, please fill them out and give us more details on them. And above all, please think about presenting on these at our next plenary. Just get in contact. And don't forget, you can also use our website to post news on what your projects are at and what they're doing. Next. Okay, so now we're going into our lightning presentations, and we're going to hand over to Alex to start with. And Shelley's going to drive the slides and Alison is going to make sure everyone sticks to 3 minutes. Go, Alex.
Come on up and here's your slides and kind of be near this mic.
All right.
Hi, Alex.
Thank you.
Oh, sorry. And next person, get ready to come up after Alex. Right, I'm going to be quiet now.
So the strategy is to form a line of presenters right here, and then we can keep going. That's about the idea, I think Leslie means. So I'm Alexander, a coordinator of the World FAIR project, geochemistry project. And World FAIR has received funding to start from June last year. It's a very large project, or there's a lot of people involved in the project. There's 11 case studies. And you can see on that petal diagram that they're organized in thematic parts. The geochemistry, for you relevant part, I guess, in the Earth and Space Sciences, is thematically organized with the chemists and the nanomaterial group. So it's funded by the European Union and the Committee on Data from the International Science Council and OSCOPE. So started in June 2020, the World FAIR project really focused on cross-domain interoperability. And so, as I said, we are with geochemistry and IUPAC in a similar theme, and the FAIR implementation profiles that you'll hear more about in about a couple of minutes are used to look at what is technically similar between these work packages in terms of making data fair. So that's for the cross-domain interoperability. The geochemistry group has organized itself in one geochemistry with a bunch of very specific data infrastructures, very domain-specific repositories, and more generic or other repositories that are more metadata specific instead of relational database oriented. And I had a chat with Pangea this week, which was interesting. And we not have them in the one geochemistry group. It might be good to incorporate them, and also new groups, of course. I don't know of, let me know. So that'd be a good thing. The World FAIR geochemistry deliverables are here. Formalize the network. We managed to become the co-data working group, the one geochemistry co-data working group. And we're focusing on publish best practices and make those more available for the community through, thank you. So make these best practices more available to the community and facilitate integration of those best practices in repositories, together with standardization of geochemical data. So that's me.
Yeah, is Carrie here? Carrie Levin?
She's online. Go, Carrie.
Oh. Hi, Carrie. Go for it. I'll advance for you.
Carrie, where are you?
You're on mute. Oh, we can't hear
Can
you
you hear
anyway.
me? Can you
Yep.
hear me now?
Yep. Great.
Sorry about that. Double muted. So I'm Kerry Levitt. I'm from the Australian Research Data Commons, and we have just launched the Planet Research Data Commons, which is national scale data infrastructure for Earth and environmental research and decision making. So next slide, please. So we have broadly, we have 3 areas of focus. The first is trusted data supply chains. And this is where we're looking to uplift capability for delivering data from research and government industry to mainly to government for decision making, for operational purposes, for reporting, and for policy making. And so a lot of that work will be on standards, so standards for data governance, collection protocols, sampling protocols, metadata and data standards, data exchange formats. A lot of big emphasis on quality and provenance, because we know that you need to be able to trust the data to make trusted decision. And we're also looking at embedding the CARE principles for Indigenous data governance. So we're also looking at fair data sets and services, which is what it says on the box. And this is across our fellow national research infrastructures in Australia for the Earth and Environmental Sciences, as well as for research and government. So we're looking at enabling more integrated fair data sets that are analysis ready. And finally, foundational infrastructure for modelling and decision support. So providing that underpinning, that sustainable infrastructure that virtual research environments or platforms or tools can build on top of through using reference architecture and, again, standards. That's it. Thanks.
Barbara's next.
Yeah, I'm happy to present to you the approach that I had co-developed together with Eric Schultes from GoFair, called the FAIR implementation profiles. And all started with the challenge to address the task to assess the fairness level of the data and metadata in the ENVRI research infrastructures. And we started with a questionnaire, which was very long, and then we could really condense it to the real important digital objects that we want to address and to catalog based on the FAIR principles. So we identified the FAIR enabling resources as the digital objects to provide any functions needed to achieve some degree of fairness. And the collection is the FAIR implementation profiles as a machine readable output and of human community agreed decisions. Next. Oh, no. The big one. Okay. So this is all based on an ontology called the FIP ontology, very easy ontology, lightweight, concentrated on the FIP declaration, declared by a FAIR implementation community for the use of available FAIR enabling resources or FAIR enabling resources to be developed, because this was also an important request from the communities to address each of the FAIR principles. So we try to identify the different types for each of the principles, mainly, for example, you see here metadata schemas, vocabularies, etc. And these are mainly specifications, services, or documents. And the last, the R1.3, is understood as the collections. The FIP is addressing this community specific decisions and serve for addressing this principle. And we express each of the FAIR enabling resources as nano publications, which allow machine readability and which allows also to reuse existing resources described, for example, in FAIR sharing. And but we need more than those resources, so we had to find a common way how to express this. And this is very useful because it also includes provenance and authorship. And we use the data stewardship wizard as the and we leveraged it for this purpose, which is the FIP wizard. Is a questionnaire-based approach, very easy for users. And we use as drop-downs the nano publications so that people can reuse other resources or mint their own resources on the fly. And this allows us to have human readable, but also machine readable outputs as a list of each of these choices, but also to compare them across communities and make comparison and converge. Thank you very much.
Shelley, you're next.
Hello, I'm Shelley Stahl. I am the Vice President for Open Science Leadership at the American Geophysical Union. And I would like to announce the most beautiful thing that's happened in the US around open science is the Year of Open Science for 2023. In case you didn't realize it, we're in it. Good to know many of the agencies are actually looking at a multi-year project, which is great because you all know that we have quite a lot of work to do, and getting ourselves coordinated is like #1 on the list. So we just had on January 11th the announcement from the Office of Science, Technology, and Policy out of the White House, and I've added a little bit of formatting to what is essentially a paragraph on what they are including, and they have a definition of open science that they're providing to us. So working internationally with RDA, we realized that there are other definitions, including the UN definition. We're very sensitive to that, at least at AGU we are, but this is where we're working from. So in the slides, you'll find the link if you would like to read the whole thing. It also walks through how each of the agencies are going to be approaching it. And a really huge credit to NASA for having spearheaded this and pushed it through, and very grateful for that effort from them. So that is what's happening. And if you would like to ask me any questions, you can do so later, especially if you are offering a glass of wine. Next slide. So in a completely different note, you might be aware that RDA has a type of group called Community of Practice. At the moment, there's only one around agriculture data, and we had an interest meeting. You might have missed it. I tried to get to as many folks as possible on February 6th. Don't worry, it was just an interest meeting, and we're going to go ahead and stand it up. If you want to be part of the co-chairs, by the way, you're all just going to come with us. Leslie's having a really deep conversation with the Earth and Space and Environmental Science IG co-chairs, Danny Kincaid, who is here. Danny, you moved. There you are. Danny Kincaid's right there. Myself, Leslie, Helen Glaves, who's from Europe, and I'm missing one. Pedro. Pedro, did you sneak in? No. Pedro Carrera, who's from Brazil, the University of Sao Paulo. He's also here at RDA. He's probably presenting right now. Otherwise, I'm sure he would be here. We likely will consider the future of the IG. So don't worry, you'll be considered as part of the Community of Practice. If you've not signed up for the mailing list for the IG, please do so that we can make sure we communicate with you about the Community of Practice. And we're going to try to find some, not try, I have a source. I have a source of funding for our community manager, so we'll be able to have a little bit more structure around that, and invite other types of stakeholders into that conversation. And I had 2 slides. You mean I'm going over? Okay. There is a survey. If you would like to provide some comments on it, grab the survey link and please go ahead and add your thoughts in. I'm just showing you the agenda from the interest meeting. It was very lightweight agenda, so you don't feel like you missed out on anything. And these were some of the private comments. These were some of the, they're not private now. These are some of the comments submitted about the kinds of things those that participated in the interest meeting were thinking that would be a great place to address. I love these comments. So hop onto the slide, go through them, feel free to add more, and we really hope that you can join us as we try to take the concepts around the earth and space and environmental sciences larger and looking specifically at how our discipline pulls in the recommendations and tunes them to our community. Next slide. Martina.
Martine.
So we need some links on the.
They're on the slides, and you all have access to the slides. The link is on on this particular meeting. Go to the collaboration notes. The slides are there, and you can have access.
And I'll put them in the chat.
Yeah, but we in the room can't get that.
It's all right. Don't interrupt her.
Yes, Gina.
Okay, so there's another new working group which started here from the interest group, and that is the Complex Citation Working Group. It was established just a couple of weeks before this plenary. The motivation or the problem that we target is that in a research study and then in a paper we want to cite or scientists need to cite hundreds of different objects, not only data sets, sometimes data subsets, software, physical samples, and they are stored in different or multiple repositories. And it's still not possible to cite such an amount of different objects in the reference list. And what we need to do is to get the credit where the credit needs to be. So to all these authors, and the idea is to have something like a composite, we call it repository, reliquary. And the idea is that in the reliquaries, we have the capacity to put all the different objects in. And the challenge will be to have a system so that you can assign the credit to the elements within there. So we have different pieces in there. We have a technical piece, the reliquaries and the maintenance piece, so which is more a governance part. And in the end, to bring it into these established credit systems, so like the impact metrics, and everything needs to be easy to use to get the uptake. We are currently having drafted some reliquaries for the 3 use cases we have, and we had a really good working group breakout. It was very lively discussions. We got a couple of new use cases, especially from other domains, which is good because we don't want to focus only on the earth and space sciences. The next step will be to include more groups, not only for the use cases, but also map the landscape, what technical solutions are available for us, and then to make a real work plan and set priorities of what we want to do. At the moment, we have so different pieces that we want to tackle just to make it a bit more clear what our priorities will be, and set up meetings and invite you. Please join the mailing list so that you get in the information loop and show up and provide your use cases to us.
Danny's next.
Yeah. Okay, big button. This is a quick summary and another plug for joining an emerging working group that is trying to address friction that is emerging in the data publication workflow as it relates to the scholarly publication. So as we all know, journals are now increasingly requiring that data supporting the manuscripts are being deposited, should be deposited into a repository to provide a DOI and a DAS, preferably a domain repository. The workflows of each of these activities, the manuscript and the data publication, are not really in sync. And they're causing some bottlenecks in domain curation workflows. And we feel that this is a pretty tractable and solvable problem, primarily based on a lack of communication and awareness of these challenges for the needs of both communities to get the publication that supports the manuscript. So this emerging working group is trying to reduce that friction that's currently present between these two workflows. As a repository person, I can kind of reach into the repository community and get some people interested in this, and there are folks interested, but I don't have a strong reach into the publisher world or the journal world. So we're looking to find people on the journal side who would be interested in working on this problem. I have a small group that met just this past February, and we're working on a draft case statement, and we hope to create a set of recommendations that would help streamline this publication and make the data available in a timely fashion for the manuscript. So there is we have a presence at RDA. So we do have the coordination of data preservation with peer review process working group presence. We're not endorsed, obviously, but all the links are there. We welcome you if you're interested in this, especially if you have connections or are a journal person yourself. We think this problem is very tractable, and this is our next steps. We're going to work on the case statement, apply for endorsement, get the work done, craft a set of recommendations that can go to each community and hopefully alleviate these bottlenecks. Any questions? My name is Danny Kincaid. You can reach out anytime. Thanks.
Wow,
You're
Shirley,
you-
we finished ahead of time.
Yeah, yeah, but Allison's coming, so you know.
No, I was just wondering, does anyone want to ask questions of any of the, just 5 minutes, quick questions?
Yes, you've got time.
Yeah.
Barbara, hang on. Here comes your microphone.
I should hold. Do you hear me?
Yes.
Yeah.
Okay. I have a question to the complex data citation or so new group. Yeah. You are collecting the 100 different types of objects. Do you have already a catalog? I would like to see this catalog. Or, yeah, I'm also working on finding out what are these different types of.
We have collected 3 use cases, which mainly drove the case statement that we proposed for RDA. So we have a use case from Deb, where she combines or says, sorry, I start again. So the use case is that there are a lot of data sets which need to be cited and which are stored in different repositories. So that's where we start off with. So they have a DOI, they are stored, but the problem is you cannot cite them. So, or
I think you were asking about the types of objects. And so not only, so anything with the DOI, and then we also want to include other types of identifiers, IGSNs, even just URLs. But we all know that the infrastructure that's set up is really catering the DOI. So we're working with the infrastructure to see what can be done, but nonetheless, it would include any digital object, period. Thanks. Just translating. Does anybody else have a question online or in the room? Leslie, you're going to have to help us with online. We can't see the chat here.
Stephanie has asked Danny as to whether we have talked to the data policy standardization and implementation IG.
Just connected with them and we hope to connect.
We just connected with them and we hope to work with them closely going forward. Yes. Go ahead, Alex.
I just have a general question which applies to many of us. And implementing our recommendations, we come up with recommendations often, and I'm sitting at the kitchen table with my brother, and he says, "That's going to end up on the shelf in the library. It's not successful if it's not implemented, right?"
True. Yeah.
So how do we do that? Probably no answer today.
Well,
we need to implement things that we recommend, or facilitate the implementation thereof, find funding for these implementations. I don't know.
No, you're so right about that. So I'm also the co-chair of the organizational assembly here at RDA, and you happen to have the co-chair for the technical advisory board right behind you. So one of the requirements for new working groups is that they actually have an adoption plan. And I think this is brilliant. It's a bit of a burden on the co-chairs to actually think that through and make sure they're pulling in potential adopters. But part of the like the new complex citation use case working group that I'm supporting with Martina, we actually had to identify who the adopters are. So we had done all of that work. We did put that in there. And then any new recommendation goes to the organizational assembly to be discussed in front of potential adopters. And I got to tell you, that has been the most brilliant thing ever, because it's like presenting the nuggets of jewels that are coming out of RDA straight to the organizations that care about them. So if you think there's a particular recommendation that could use some more highlighting, let me know, because you could present to the organizational assembly.
Okay, I think it's time to move on. I'm being Dracula here. It's now, can we have the next slide? We're moving into our deep dives. We've got two, one on PARSEC and one on ENVRI-FAIR. So I'll now hand over to the timekeeper, who I know will keep immaculate time on her talk.
Yes,
Over to
I've
you,
got,
Alison.
right, thank you. I just check first the slide moving. Oh, great. Good. Okay, now I will press start. So having been nasty to everyone else, I had better be good myself. Okay, it's great to talk here today, to have the opportunity to talk about our project, which is nearing the end. As you can see, we started in 2019, the beginning, well, halfway through thereof really, but anyway. Please note the website there, which gives a bit of a trajectory of our activity. Okay, just to fill you in, PARSEC is an acronym, if that's the correct term, for a title which is basically about the effect of protected area, the creation of protected areas on the socioeconomic well-being of the adjacent communities. And the unique components thereof are to first conduct the synthesis science, which is doing the deep learning and remote sensing, etc., and getting the sensor stuff together for the particular science question I just mentioned. But the second part, because we were funded by Belmont under their collaborative research action, which was science-enabled e-infrastructure innovation, to test novel approaches to the management and preservation of environmental and socioeconomic data. So our aim at the beginning, and Shelley and I were the the people who put it in, to put it in easy words, was that these two strands would learn from one another. So it was a unique opportunity to have a closely allied set of data scientists together with normal synthesis scientists working multidisciplinary synthesis scientists working beside one another, and therefore they could learn from one another. Okay, so just to give you a picture, again, this was a requirement of the Belmont Forum, and the funding that came in for this particular initiative was to have several countries involved. So we have Japan, the USA, Brazil, France, and our wonderful Australians who just do it for love, not for money. Anyway, so it is a transnational, and you can see on the right there, it is an interdisciplinary project. Now that little slice was from a data use survey we did at the beginning, and these were the sorts of data types people in the initial group used. We've grown to 48 researchers now. We've definitely got 4 languages. Initially, Shelley and I knew a total of 10 people, and so you can see that from that kernel, the larger group grew. There is a note there about 36% women. If you read the paper in PLOS One by myself and Kevin Crouston, the end of last year, you'll see why that is a significant figure, but we will not dwell on that. Anyway, the context that we had was that this would be a sort of working group, a la Synthesis Centre, for those of you who know about NCIS, the Synthesis Centre in Santa Barbara, several others. CESAB was the host. I was the director of CESAB at the time. So the idea was that we would use existing data and we'd put people in this fairly structured environment that we knew had been fairly tried and true to help support transnational, multidisciplinary, difficult working groups. With a bit of scaffolding around them. And of course, the execution was to be a nice linear thing with, meetings every 6 months. So of the 10 people who Shelley and I knew between ourselves, they could get to know one another for the first time, most of them. And of course, the other 38 that joined them would also get to know them through this particular process. And of course, the normal research outputs, publications, conference papers, getting feedback from your community, and so on in the process of this 4 years. And by this means, we would develop trust between the parties who had previously never known one another, and they would share their intellectual property, their data, and that sort of thing. But of course, and we do that via these meetings. And of course, then there was COVID. So that really, we had one meeting and not everyone was there yet. So it was particularly difficult, but we adapted. So part of the thing that my team, because this is a team-produced presentation, I'm just a spokesperson to a large extent, we adapted. And one of the things they wanted to say, and I can't say enough about it really, is how we adapted. Shelley ran 2 meetings a day every fortnight to cope with the time zones. Now, there are very few people who would do that, but Shelley did, and that was enormously important because it did that sort of consistency. I wake up at 9 o'clock in Australia and daylight saving time, whatever, and every second Thursday morning, and we'd be there. That sort of consistency was wonderful. We did manage to have the 6 monthly meetings. They got better and worse depending on what problems we had. And of course, we participated in conferences, including many RDA conferences. So that trust was gradually developed. And I'd say we're pretty good. We actually do, and we've got some people here. We actually care for our fellow members. They're part of our family. And we've had 2 face-to-face meetings after that first one now, which has certainly helped. Not everyone could go. So outputs, this is what we were asked to produce for your talk today. Okay, I'm doing quite well. Responding to our researchers. So we've done a few things. One of the key things, remember these data strand and researchers were working side by side. The data strand people turned up with their thoughts in their head, right, repositories, metadata, stuff like that. And of course, the immediate response was, well, we want to get on with this business. We're doing all this satellite image downloading. What are you talking about? Just leave us alone, was the reaction of the research team. So that was excellent because that's what we kind of expected, or some of us did. But here are some examples of 2 contributions. I do have to mention the data and digital object management plan that the Belmont Forum had devised for us, and we more or less did one of the first exemplars of that. And we've done 2. And this particular one is, there's Mark, is for a paper, is a diagram in a paper which is summarising what is in our data management plan. It's pretty elaborate. The first one was 40 pages. Shelley's largely responsible for that. I'm responsible for the diagram. That's about the depth of it. But yes, it's quite a major exercise and has been downloaded and used quite a few times because we put things up on Zenodo, if you might notice. So we get counts and all this sort of thing. So it's quite nice. The other major output so far, and it's by no means the only one, is this idea of the of something we've ended up calling the spiral, which is about one's development as a researcher, because we found with these researchers that they particularly, that to address them, number one, to address their heart, their well-being was a jolly good way to start talking data, to start talking open science. They're ORCID. They know about DOIs on their papers if they go to the right journal. They're really taking up ORCID, and we had a session on Monday, and I was, just the take up of ORCID has been fantastic. So you start with that, you feed into their egos, if you like, and their career progression, and then you can move a little further into data documentation. And indeed, heck, you can get that cited too. And of course, we hope that it will be cited in a systematic manner, and that's where you all come in. Software documentation, we're doing quite a bit of that. I'll show you some examples. Open science practices for teams are for the research team. Now, we've got those 6 there. If you look at the QR code, and of course, these slides are up, you will see that there's another 6 moving forward, and you can see all of these. And for example, here's a little snapshot of the start of the digital presence checklist, that first one that plays to the ego, to the id of the researcher, making it fairly obvious to them that this is worth their while. You start off, have you got your ORCID? Have you got your own ORCID? Include your ORCID on all scholarly work and that of your co-authors if you can. Keep your ORCID profile current. I've got to go back and have a look at that. And we've got a bit of a timeline for these sorts of recommendations, how often you should do this. So hopefully, you know, this sort of thing, and I put et cetera there, not that you're going to see any more, but there is more to the actual guide or checklist, if you will, that will help the researcher. And that's something that seems to be getting some traction with our researchers and therefore hopefully with the others. Now, remember, our researchers are distributed. They're not all together in one lab, although I must say the French seem to have a very big lab. But sorry. We have some scattered researchers in other countries, in the other countries. And thank you to the Brazilian team and the Japanese team. There's some really good integration going there, and there's some other integration elsewhere with the Australians and the US and that sort of thing. Okay, so there's some of the data things that Shelley, who's the leader of the data science strand, has been beavering away, working on and responding to as we discuss things and work alongside these synthesis researchers amid all of their problems. Now, remember, as a synthesis centre director, you know, of 2 synthesis centres and, of course, knowing several others at the time, it is very well known that if you give 4 years of a research project to a science researcher, they'll take up the first 2. If you give them 3 years, 1.5 years, it's kind of automatic, collecting their stuff together. Even if you ask them for a data management plan, that they've got their data available, they will still fiddle around for the first 6 months or half of the project. That's not exactly unusual. So we just might mention that as an aside. But the Brazilian team, with some extra funding for PARSEC, which had given the original funding to the Belmont Forum from their country, Pedro Correa, who's here, there he is, managed to get some more funding, managed to get a little bit of a team going. So they've been actually going great guns, really going great guns. We're very proud of them, I think we can say. So here are some things that they've nominated to mention today. Now, I'm not going to talk about all of them. We'll probably let the last 2 drop off because they need much more development and talking. But I'm not going to talk about all of them because of time constraints. But you can see there are 6 really neat, shareable things. So the pipeline or workflow. So this first one. This is a workflow for deep learning applications, satellite images, street view images, deep learning applications of images for predicting socioeconomic indicators. So you start with the ground truthing of the socioeconomic data set via census figures, that sort of thing. We do big scale. We're not doing those lovely little surveys that many people do and would be great, but we're doing satellite imagery. It's a bit of a feint for the project. Then we get the various remote sensing. Our first effort was with Google Street View images, for example, to kick off and test this procedure. But we mentioned there the real game, which is supposed to be multispectral Landsat and night light images. And of course, we need time series, time space. So that's quite interesting. It's one of the first times that double whammy has been tested for this sort of method. The data pre-processing takes quite a bit. And of course, the environment in which all this happens is quite important. And then you can get your deep learning model set up. So that is now almost off the shelf. So it's pretty neat. The next one that I'm going to mention today is preservation and share of source code. And there on Git is a whole pile of source codes that they've got, that they've posted there for open access and use. So they've been, you know, it's all sorts of things and pieces of code and whole bits of code that the coders often will take and via Jupyter Notebook or whatever and use in their projects. And and there's a bit of feedback there too to the project. There we are. Okay, one of the things that I think is particularly innovative is the sharing the deep learning trained model as a checkpoint. So this is for other people working in deep learning to have a benchmark and checkpoint that they can use to validate their model or whatever. And this has been tested in East Africa, which is where the French team has been working quite a lot. They've got a very big project there that has been progressing, taking a while, but it's still progressing. And they've tested it in Brazil as well. So it's pretty good. And the trained model is not quite released yet because we're preparing a paper. So the what do you call it? The credit can be given to the authors properly. Okay, and also all the other exercises we do can be properly referenced. At the moment, the transfer of that is being tested with the team in Japan and a time series analysis there. So it's really quite, it's being used in a fairly flexible manner. So that's quite good. Now, the last bit, which is kind of more general, but this is towards the end of the project. So this is a kind of reporting. There are other things. There's the general things. For example, here we are. This is a sort of productivity. I went to our nicely designed in our DDOMP spreadsheets that we have that we report on every year with the Belmont Forum and all our various research officers in our countries. This is our accumulated productivity, plus or minus, no, minus a couple, because I know I've missed a few. But that's certainly the refereed research articles are remarkably high. I didn't realise that. There are a few in Japanese and things like that that I added this morning. I was sitting there at 5 o'clock, adding these up in the dark. Thank you, Leslie, you note that. We've got posters, and I call out Romain David, who many of you will see. He's been an enthusiast. And of course, one of the things he's looking at and very keen about is multilingual vocabularies. We've got a 5-country team that really often hits barriers of communication, I assure you. And of course, the aforementioned guidelines and checklists. And by the way, the conferences that you may have seen, oh, sorry, wrong direction. I won't be able to go. Oh, dear. Will I be able to go back? Oh, yes, there we are. There we are. There we are. Okay, the conferences there, many thanks to Shelley, but she isn't the only one, and many thanks to RDA, but you're not the only conference. But anyway, but we deliberately have found the RDA a pretty good target because it's a way for us over the series of the project for the data strand to get community feedback, to get ideas, to get, and and of course, we are in a partnership with Shark, who's got their workshop this afternoon. So rewards and credits. So do go to that. Okay, so things to do. This is what Leslie and you, Pedro and Shelley, and probably Danny as well as leaders of the ESIS group, asked us to talk about. Well, we're going to further the guidelines and, they're up there, sure, you can have a look, but we'll be translating them into different languages. First, our languages. That's quite enough for the moment, and a couple more. I was hearing some awesome phalanxes of 13 languages and stuff, but anyway. Publishing a paper on the deep learning code, I mentioned, so that we can properly publish with validation the code, and Margaret O'Brien is helping us greatly there. Publishing a paper on the data pipeline for a major global database, which I haven't written there because its ears might burn. I'm going to talk to the manager tomorrow, or the director tomorrow. But yeah, we've been accessing global databases and then finding the scale and resolution. We did find that with the census stuff is quite different when you get to country level or different scales. Publishing a reflective paper on the 4-year process. Gosh, that's actually quite big. But we do have a list of 10 other papers that are on the go, and they're all in our special folder as determined by the DDOMP. And people are going there, one of which is socioeconomic terms, by the way. Different in different countries for the same thing. So that's created a bit of interest. So here we are. We have formed a team. I don't know how much I can say about that, but we are a team of friends. This is our first meeting on the top left when we went to Montpellier. We were supposed to go there about 6 times in between, but this was the first and only time we've been there. We didn't really know one another very well, and they only had one room. They now have got lots more rooms, so that's really lovely. Then, of course, we went to the Zoom mode. There's a little slice of that, which wasn't quite the same. I first met Shelley at the RDA in Philadelphia, and I was quite sure she was 6 feet tall. Wouldn't you be? Sorry. And yes, we met eye to eye. That was very bizarre. Then we had a meeting, and finally we got together. Many of us had a meeting in Colorado at the USGS Synthesis Center, and then the last meeting was in Sao Paulo, together with a data science workshop, which was pretty interesting and special. We had a field trip there too. But anyway, thank you very much indeed for your attention. And I'm just a wee bit over, Leslie.
Okay, that's fine. Troops, we can have 5 minutes for questions. Does anyone want to ask Alison about this fabulous project that's been running now? It was funded by Belmont, multilingual, multi-country, and really shows what can be done across borders.
Yep. So we're so grateful for our funders. So as you know, Belmont doesn't provide the money directly. So for the United States, jet lag, the National Science Foundation was incredibly generous. FIPESP from Brazil, ANR from France, JST from Japan. And we do have quite a number of RDA members that are partners with us on the project. Kaz is here from Japan, which we are so grateful for. I do believe some of those presentations Kaz actually helped me arrange, or Moriyama-san did. That was multi-country presentations on behalf of PARSEC. And we'll have another one coming up at JPGU very soon about that. And then from Brazil, Pedro is here and just has been a powerhouse, has hosted one of our incredible postdocs. Our other postdoc is out of France. And did I miss? And Margaret, our partnership with the Environmental Data Initiative, our domain repository of choice. Well, the people in the room, I'm saying the people in the room. Yeah, yes, that is very impressive. ESIP, of course, our Science Information Partners has been incredible. And really, huge credit to, stop, get over here. Huge credit to Alison, who has brilliantly built a community and helped everyone feel very welcome and appreciated, and everyone got out much more than they gave. And I think it's safe to say that was really Alison's doing.
And it's beautiful.
And she hates getting credit. So, all right.
Anyway, thank you very much for your attention. But yes, we usually give the Indigenous Heritage Thing and of course the acknowledgement to our funders. But Leslie had terrified us with respect for time. So.
And for those of you online, Alison continued to speak. So here we go. Let's see. Yes, I think we've covered that. And Keith, my friend, you are up next. ENVRI, I'm so excited to hear an update on ENVRI because I know it has progressed so much further from our last session. Keith, the red shoes are rocking. Keith Jeffrey, who is here to talk about ENVRI.
Hi, everybody. You'll have noticed I'm not Helen Glaves. She's unfortunately indisposed, so I'm standing in for her to talk about ENVRI. I'm Keith Jeffrey, past director IT at the UK Big National Science Lab. The important number is we had 360,000 users, from particle physicists at one end to performance art at the other. So quite an interesting group of people to work with. But actually, my degree and PhD from the 60s are in geoscience. So I actually am an environmental scientist. I'm even an elected fellow of the British Geological Society. So, okay, so I'm going to talk about ENVRI. And I like our slogan, life isn't fair, but our data is. So I'm going to give you the general context of ENVRI and then take you into what we're actually doing in the way of dealing with fairness and interoperability and all that stuff. So I always like to start with a scenario. Here's a typical one from a geoscience point of view. And the key problem is it requires interoperation across all the environmental domains and even further out into other domains. And that's where, in the European context, the science clusters around the EOSC come in. So we can cross-link to the social scientists, we can cross-link to the medics and the biomedical people, and so on. The real problem is finding the assets, the digital assets. So this is what ENVRI looks like. We've been going for about 12 years over 3 projects. ENVRI-FAIR is just coming to an end in June. And you can see at the bottom of the slide there, the RIs, the research infrastructures involved in ENVRI. So here's our overarching goals. And what's really important about these goals is you note it talks about data services, not data. Although we have a lot of metadata on data and data products, we're very, very concerned to have metadata on data services, because if you have a highly distributed network, you need to have data management at the leaf nodes, i.e. services, executing code in order to reduce the amount of data you ship up the network towards the supercomputers at the center. So our 2 key things we have to achieve is fairness and interoperation with the EOSC, the European Open Science Cloud. This involves technical interoperability, that's the fun bit that we all like, and it also involves the boring bit of governance interoperability. If your licenses don't match, hard to interoperate. If your way of dealing with personal data privacy doesn't match, you could be illegal. If you don't have the appropriate policies in place for cookies, then it's very, very difficult to move cookies across a distributed network. So there are very good reasons to make sure your governance is as good as your technical interoperability. So 2 things, FAIR and EOSC. Let's start with FAIR. We had 2 approaches within the project to FAIR, the pyramid and FIPs. FAIR information profiles. Here's the pyramid. This is something that we did in the EPOS project some time ago. And our idea was to map the FAIR principles on the left with technologies on the right to be able to deal with the various levels. After all, the overall aim is, starting from the top, to accommodate the researcher mindset, make sure we provide to the researcher that which they need. And the slide deck's available online, of course, so you can look at this in detail. I'm sorry about the size of the text, particularly on the left side. But the key point is that we matched the FAIR principles across to technologies, so we knew where they fitted as you go from data to metadata to access by means of services, and on to actually the use of services by the researchers to do real science. The other approach we took when it emerged is FIPs, and Barbara's already talked about FIPs this morning. So you know that what we did, we used it across the ENVRI-RIs. And it's okay for data sets, but it's not so good for the other stuff that we're having to deal with. Right, implementation. How we actually did it, and this is all talking about the interoperability and the catalog. So we had 3 goals for the catalog. The first one is cataloging the digital assets of all the RIs in the ENVRI domain. And as you know from my second slide, there are quite a lot of these RIs in the ENVRI domain. The second one was to provide the starting point for access for the end users. And the third one was to interface to EOSC, but also, of course, ensuring we were fair. So we have some interesting problems with our catalog landscape. Each RI has different data in terms of type and granularity and all these things. And it's not just data we have to deal with services and software and scripts and workflows and a whole lot of other stuff. And we also have to deal with lab equipment and sensors and sensor networks and their connections to say nothing of the data storage. So we really have an interesting load of things to deal with. The second thing is that there is different levels of maturity among the RIs. Some RIs are really mature, like ICOS, for example, in the atmospheric domain, and others are just starting out as new RIs and trying to learn how to do all this stuff. So we had discussions about this in the task force working on catalogs representing all the RIs within ENVRI. And we decided, first of all, we needed a rich canonical superset metadata standard. And the reason for that is if you broker or convert between every pair of different heterogeneous metadata standards, then you get basically an n-squared explosion. Whereas if you convert them all to one, then you reduce that to n, so it becomes tractable. We chose the Serif data model, and we chose to do the ingestion using EPOS DCAT AP because that's quite a nice linearization we can use, and it makes it easier. In just one RI, EPOS for solid Earth, then we had to convert 17 different metadata standards. So it gives you some idea of the scale of the problem. Serif, there's some information about it. This is really for reading later, but the key points are it's a fully connected, decorated knowledge graph. It includes temporal information and optionally modality, i.e. probability, which is kind of important in science, especially if you've got Heisenberg around. It has built-in provenance and curation. That happens automatically. It allows both vertical provenance, i.e. over time, and horizontal provenance, what's happening at this time, which is really very useful for various purposes. It's got a syntactic and a semantic layer using the same structure, and that then allows you to maintain the ontologies which drive the information in the syntactic layer, such as restricted terms like country codes, or roles in the relationships between the different entities, like the word author. So you can assert that person X authored publication P, or you can change the authored to scritta da if it's Italian, and that gives you the ability to handle multilinguality. It's extensive, it's used all over the place, it's even in things from publishers such as Elsevier and Thomson Reuters. And it's an EU recommendation to member states for 30 years, so it's quite a long-term thing. So our ingestion pipeline looks like this. We get lots of metadata records from the different RIs in ENVRI in heterogeneous formats. They're converted into this EPOS DCAT AP standard. AP is an application profile. Validation is done by Shapes and Shackle, the constraint language. And then we do a second conversion into Serif, because Serif is quite frankly pretty complicated to get your head around. But from Serif, we can then convert to many, many different metadata standards, so we can interoperate bidirectionally with all sorts of things outside the ENVRI environment as well as inside. Just to give you an idea for catalog ingestion, the bit in, don't worry about trying to read it, the silver boxes are DCAT, and the golden boxes are the extension we had to make, and we're still extending. So you can see the scale of the problem. We really have to push out the boundaries to get the information we need in order to allow interoperation across these heterogeneous RIs within ENVRI and indeed going to the outside world. So let's look at the architecture and user access so you get some idea how this catalog's used. There's the standard diagram. So the catalog, does this work? No, it doesn't. So the catalog is roughly in the middle, purple thing, Serif, and below are the different RIs with their APIs and how we do the mapping across the interface to get to our catalog with the appropriate integration software. And then that has an API, so you can have different user interfaces to it using that API. So you can swap user interfaces if you wish to have different levels of accessibility. And we can also convert out to DCAT using RDF, we can go to Dublin Core, we can go to CCAN, a whole lot of other standards out there that we can use. The user interface was kind of partly inspired by what we do in EPOS, in Earth Science. So that's the EPOS user interface. So you pick up a particular selected digital asset. In this case, the service giving you the European database of seismogenic faults. And basically that means earthquakes. And the little orange lines on the map show you where these nasty places are you have to worry about and where you have to have sensors to monitor everything. But you can combine layers and do all sorts of clever things with this interface. But you can also, by clicking the little eye that occurs on the block of each of these assets, top right, there's a little eye. If you click that, you get a load of more detail. That's just one of the pages of detail. It goes on and on and on. And also this allows you to reconfigure the parameters of the service so you can execute the service using different parameters to get different results. Now, what we're doing in ENVRI is building the ENVRI hub, and the builders are right here in the room. Hi, Uli. So the ENVRI hub is being built, and the ENVRI hub is, because it has to interface with EOSC, we're actually moving to the EOSC style, which is using a thing called a marketplace, which means that you basically have a search and a browse function over the digital assets. So this is the top part of the interface or the page. And you can see that at the bottom left area, you've got boxes where you can put terms to do retrieval. And if you move down a little bit, then you have the digital assets. And over on the right, the same sort of thing as you saw on the EPOS thing, a page of detailed information about the digital asset itself and all the stuff you need to be able to utilize it. So what are we doing next? Well, this is what we have to do for the catalog. We need to obviously ingest further metadata records. We've got quite a lot, but we need a heck of a lot more. We are providing support to the communities for the metadata conversion. So the catalog team are doing this work, and we've also done a lot of training courses and workshops and so on. We're doing initial work on making the vocabularies consistent, or at least interoperable. There are several initiatives in that area in the ENVRI community. Catherine Exter at the Flanders Oceanographic Centre is doing work, and also Alexandra Kokonaki from the British Oceanographic Data Center is doing work on these vocabularies. And there's a whole team at INRIA and in France working together with BRGM, the mining institute in France, on doing rather interesting work on vocabularies. So we're bringing all that together. The next step also is improved integration with the ENVRI knowledge base, the scientific use cases, and the training system, and of course, EOSC onboarding. And the current view in ENVRI is that we will not onboard from each individual RI, but we'll onboard through the ENVRI hub. And that has some advantages like providing a clean interface, which then means we can manage to as changes occur in EOSC, we can insulate the whole ENVRI community from those changes. So that's the kind of final picture with the knowledge base on the left and the use cases and the training stuff over to the right, and in the middle, the catalog system, which is bringing together the metadata records into a homogeneous format from the heterogeneity of all the different RIs. Thank you very much. Well within time.
Does anybody have any questions? Anybody online?
There's no questions online.
I think we have one here.
Okay,
Go ahead. Go ahead. Hold just a second, Leslie. Go ahead, Rob.
Yep. So the Serif implementation
Over
looks
here.
like you used relational databases to map to knowledge graphs. Is there any
Exactly.
Here,
is there any
Keith.
reason the relational databases were chosen versus a graph
Sure. We've done a lot of work on triples and found that it doesn't scale for our kind of activity. First point. Second point, you probably noticed that the linking records or the linking entities in Serif are n-tuples because we have to have the temporal information and the modality. So we went for relational because of performance, reliability, the number of tools available, the capability for managing distribution safely, referential integrity, functional integrity, and the ability then to utilize that information in a closed world for induction and deduction. Between individual RIs, you can, of course, use the open world, but it's because you don't have the risk then of dealing with, for example, negation. So for good reasons of logic, we went for relational. And that works for our community.
Thank you.
Fantastic. Any other questions? Oh,
There's
I
a
have another
question-
one. Do you have one online, Leslie? Go ahead.
Yes, I have one online from Emmanuel. He's asking, is the API to the catalog publicly available?
Yes, it is. You can find it on the EPOS website.
And then in the room, we have one. Go ahead.
I think I have a dumb question. It seems to me that you integrated data from European research infrastructures. Have you any idea about how much that may mean about the whole lot of data in research in Europe?
Wow, that is a big question.
Meaning national infrastructures or even bigger institutes which may hold data, et cetera, et cetera.
Yeah, I mean, our task in ENVRI was to integrate across the research infrastructures of ENVRI. But the metadata standard we're using, Serif, is heavily used throughout Europe by funders, research institutions, and universities to keep track of their research because it has this set of connections and because it's an EU recommendation. So it's very easy to extend outwards from any of these nodes to any other node because you have this common metadata format, which provides you with, therefore, consistent query, right? The problem with the heterogeneity is you don't get consistent queries, so you need the standard format to get consistency. Yeah.
We need you to have,
Yes, for example, ELTER is not only one node. It's made of, there are 500 sites underneath in each 26 countries, and we do there already harmonization, and this goes into the ENVRI. So it's not, we are already trying to be cross-national also here. So in each of these research infrastructures. So.
Thanks.
Thank you, Barbara. And Pedro in the back has his hand up. One more question in the room.
Incredible presentation. Thank you for your presentation. I have a question of Pedro from University of São Paulo. My question is, you have done incredible services for the community, for environment community. So how you can sustainable this service when you project, because project you have a cycle, how, because people, the community know how to use the service, how they continue to use the service, sustainability.
That's an excellent question. The point is that a large number of the ENVRI RIs are ERICs, which is a European construction. And an ERIC is a European Research Infrastructure Consortium, and it's a legal body, and it is funded by national governments. So our sustainability is that our RIs are funded by national governments collectively, and that then gives us the ability to maintain the whole ENVRI network.
Any other questions online or in the room? Oh, Barbara's got one. And thanks to Rob for running the microphone. He volunteered early. That was very nice.
I have a question. How, so we expose now a specific metadata on a high level, I think. We need also to drill down a lot, to do data integration. We need more. So what is now the plan to go into deeper level to really make data reusable across the different research infrastructures?
Yeah, okay. ENVRI has been a journey, starting with different RIs with very different ideas about how to do things, and bringing it together, converging, has been a huge effort, both in governance terms and in technical terms. Where we're going from here, we tried to get the low-hanging fruit, first of all. That is to get the basic metadata we needed for discovery and contextualization, and then we've achieved that. Serif has the capability of recording things like parameters or indicators and their values. It has the capability of linking together things like data sets, services, organizations, projects, persons, publications. Indeed, it's the underlying technology in things like OpenAIRE. So it allows you to do all this stuff. So the technical capability is there, sitting there right now. The problem is the effort required in the individual RIs to provide the information in order to get to those lower levels. And that requires two things. A willingness in each of the RIs to do it. And remember, each research infrastructure is an independent legal entity, so they can do what they like. And secondly, finding the technologies that allow us to do that, and the obvious technologies are based in AI. That is the capability to use AI techniques to discover the deeper levels of the data and integrate them using closed world assumption, safety, referential integrity, to make sure that we have consistent data upon which you can make scientific decisions. I mean, in my field, the geoscience field, people need the information to be as correct as possible, and that the simulations which give predictions to be as correct as possible, because they're dealing with things like earthquakes and volcanoes and landslips. I mean, life is at risk here. So you can't afford not to have closed world safe deduction. Otherwise, you get all sorts of strange results. So we have to be very, very careful about this. And that's why we're going step by step, deeper and deeper, to get more and more information. So in the geoscience world, we have, for example, lots of geochemical information, lots of geophysical information, detailed information about things like the precision and accuracy of the instruments, all this stuff that we need in order to do this, but not all the ENVRI RIs are at that level. Some are. The oceanographers, for example, have an awful lot of detailed information, but not all of them. So we need to try to move together to get to these deeper levels. And if I can just add, we've just started in the geoscience domain a really interesting project called DTGEO. It's digital twin of the solid Earth. And that's to deal with these hazards that I was talking about, like earthquakes and volcanoes and tsunamis, and anthropogenic hazards, that is collapse caused by mining, for example. And there, what we're doing is having massive workflows, multi-step workflows, and these workflows actually pull information from tens, possibly hundreds of different nodes around the network, and gradually bring it together with data management and analytics towards the central supercomputer network, which is the Phoenix network. Most of it's being done on Mare Nostrum in Barcelona. And that allows us to do these big simulations. But we have to make sure that we have, as near as we can, truth all the way from the end node, the detectors out there in the field, through the edge computing, all the way to our central supercomputers where we're actually running the big workflows. So it's a really exciting project. It's very difficult. And for the IT people in the room who are interested in interesting challenges, the real challenge of DTGEO is to optimize the deployment of the components of the workflow across a very complex network. And that's really difficult and requires AI as well.
You know, that is the perfect segue. Don't leave.
Oh.
Perfect segue So who would like to present at the next plenary? I would like to nominate Keith Jeffrey to tell us about this digital twin. That is the coolest project.
Yeah, it's really good.
Yeah, I can't wait to hear more about it. So, okay, now you can go.
Thank you.
Thank you so much.
Yeah, thank you, Joe.
Leslie, shall I keep going or do you want to take over?
Well, no, it's not. We've just got one more question to Keith. Kerry, can you switch on and present it, please? Can you unmute? It'd be easier if you, or do you want me to read it out? Okay, go for it, Kerry.
Yeah, so I was just wondering, you mentioned that that the FAIR implementation profiles didn't work as well for services, software, or workflows as they did for data. Is that right?
Oh, I think that one's to Barbara. Barbara's coming up to answer.
No. The question was to Keith.
Oh, back over, Rob. Keith, you're gonna. Do you want the question repeated, Keith? He was walking back to his spot.
Sorry.
Could you repeat the question?
Sure. So, Keith, you mentioned that the FAIR implementation profiles weren't as good for representing services, software, or workflows as they were for data. Did I understand that right?
Okay, so representing services, software, as well as data and data products. Is that the question?
Yeah.
Yeah, right. The key thing, well, there's several key parts to it. First of all, you need very rich metadata to describe the services or to describe the software. In the case of the software, it's mainly descriptive. In the case of services, what you have to do is make sure that the metadata reflects accurately the parameters of the API with associated explanations so people understand what the parameters are. If you look at a typical API, it has parameters which are very short text strings indicating what the variable name is, and you need to translate that into including knowing things like the units used, its precision, its accuracy, and a lot of other things. So you need extensive metadata to describe services if you're going to use them, A, by a person finding them and using them, and even more important, if you're going to do automated orchestration of workflows where you pull them into the workflows as needed dynamically and execute them with the parameters that have been defined by the end user. For data products, that's easier because they're normally either static or they're static for a period of time. So if you have something that's generated from 10 different data sets mashed up together, gone through an analytics and a visualization, and you then have it either as graphics or as a movie, then that tends to be static for a period of time. So that's rather easier, and all you have to describe is what the product is and how it can be used. And very important, refer to the provenance, where it's come from, what data sets were used, what processing was done on each of those data sets individually and then collectively to get to the end result that you have.
Nice.
Okay. So it's a description issue. Okay, thanks.
Thanks.
Add one mini sentence about
Barbara has a postlude. Go ahead.
Yeah, the FIPS are based on the FAIR principles, and the FAIR principles talk about data and metadata, not about services. So it has to do that we have built up
a scope, a limited scope. Yeah. Okay. All right.
Yeah. Okay. So I'll just put in a plug then for the next breakout session. We've got a session on FAIR for virtual research environments, which we are grappling with the issue of virtual research environments are made up of a whole lot of services and software. And so how do we provide guidance to developers on how to make those FAIR? So it's probably some really good learnings from this community.
If you could also come to the complex citations, you'll want your use case in there, please. So that you can cite everything that you're figuring out.
Okay, Shelley. So yeah, I've got it there. We know there are new projects out there. We've done the Circle of Life. We've finished off on these projects for 5 years. We're starting new projects. So please volunteer. You can have a 3 or a 5 minute spot, depending on how many positions we get for the lightning. Or if you'd like to do a deep dive, please contact one of the chairs. Now, Shelley, I'll hand over to you for the last slide because we've actually miraculously finished on time.
Isn't that crazy? So do you remember maybe what seems like eons ago that I talked to you about the community of practice for the Earth and Space Sciences getting stood up? Well, during that particular, is Lena here by chance? Or is she in a different, Lena, there you are. Okay, so Lena asked a brilliant question during that session. She said, why are the Earth, Space, Environmental Sciences not represented on RDA's discipline descriptions on the page? And I, jokingly responded, well, because we haven't had time to write that. So Lena then wrote it for us. So brilliantly, we actually have a description that we would like to submit to RDA, thanks to Lena. So Lena did, so she actually is it works collaboratively with the technical support unit for the working group 1 in the IPCC, and she makes data openly available for the AR6 WG1 report. And so here is my promo for Lena's work. You can see on the right, we don't have the Earth and Space Sciences there. So take a look. There's some commentary in the document. Should we have a separate one for climate science? You know what, if we can just start with one page, I think that would be so much better. Like in 10 years, we've not had this page. That will be hugely better, but you may have other opinions. So please go on in. If there's anyone you think should be editing it that's not in this room, share away. And Lena, you're looking for comments maybe by Monday. So now or never, people. Actually, we're going to be able to update it. So it's not really now or never. So please do intentionally go look. We can certainly make updates later, but we will endeavor to get a page, knowing full well that the website is changing in June. So. And Keith is raising his hand. Keith's going to go. Are you editing already?
I was just going to say, if I may, I can shout. So
No, online. Nope, can't shout. Come up here. No shouting. There we go. Go ahead.
I was just going to say, checking the page for this session, I noticed that fewer than half the people in the room have signed up. Please sign up on the page.
Oh, yes. In order for us to thank you so much. The metadata man has said your metadata is not on the page. Get yourself updated so you know how to get to it. So just hop into the program. Whoopsies. Nothing broke, I hope. Hop into the program, find the collaborative notes, get yourself in there. Please, please, please. Easier. I know that Leslie's been putting links online, and I know you don't have that. So you have to actually navigate via the internet to the program page. Leslie, back to you to close this out.
Yeah, look, if you do go to the web page of the session, you will get the collaborative notes. Or another thing too, please send us an email, or put some feedback in the notes on how you think the session went, whether you like the style of how we're organizing them. And above all, please come out of the woodwork and present on your project at the next meeting. And don't forget the link where I've got, thank you, Shelley's got it up, the IG, you join up there, and please put notes about your projects or anything that's going on in ESES infrastructures globally, particularly those of you from Asia, Africa, and South America. And I think that's it, Shelley. And thank you to Shelley and Alison and everyone who's been helping me there on site. It's been really hard to organize this from the other side of the planet, I can tell you.
Yep. So our co-chairs, let's just say that again. So Pedro's here in the back. He co-chairs with us here. And Danny Kincaid is also a co-chair. Helen Glaves, who's not feeling well right now. So please keep her in your, I think she'll recover just fine, I hope. And of course, Leslie in Australia and myself. And if you're interested in coming into the group as in leadership, please let us know, especially for the community of practice. We need to have representatives across 10 countries, 10 continents. 10 countries, not continents, 10 countries. Yeah, I will email the working group email with the link to the text that Lena wrote, so you can all have a look, and just in case you didn't get the QR code. Yes. And then, well, I'll email that email list. Yes. So great. Thank you, Leslie. Sleep well. Thank you, Peter.
Yeah, thanks, Peter. Oh.